What is power? How is it related to energy? What determines how much power a device uses? These are the questions students will explore in Investigation 17E, Electrical Power. How is the power in an electric circuit related to the energy output as time passes? In part 1 of this investigation, your students will create a circuit using resistors in series. In part 2, they will create a parallel circuit of resistors. In both parts, they will plot the power and energy flowing through the resistors and compare the power output as calculated in SPARKvue. For part 1, students will create a circuit with resistors in series. They should connect the 33 ohm and 100 ohm resistors in series with 2 batteries, a switch, and a current sensor. The voltage sensor should be connected in parallel across the 33 ohm resistor, with the positive end of the voltage sensor connected to the positive end of the battery and the negative end of the voltage sensor to the negative. Each group will use the SPARKvue experiment file 17E electrical power and connect their current and voltage sensors using Bluetooth. Click to start recording data and then close the switch. We will continue recording data until the energy output reaches 1 joule. Cross one. There we go. Next, we will move our voltage sensor to measure the voltage across the 100 ohm resistor. And we're going to repeat our experiment. We'll start recording data, close the switch, and stop when we've recorded data for 1 joule of energy. Stop. When we look at our SPARKvue data, we see that our power remains constant, while the energy increases steadily as time passes. The 100 ohm resistor has the higher power output because while the resistors both have the same current passing through them, the voltage drop is greater across the one with the greater resistance. Next, we'll fit a line to each of our energy versus time plots. When we look at the linear fit, we see that the slope of the energy versus time plot is the same as the power output. This makes sense because power depends on current and voltage, and with units of watts, 1 watt is defined as 1 joule per second. Power describes how quickly energy is consumed in a resistor. For part 2, students will use the same resistors to create a parallel circuit. We have the 33 ohm and 100 ohm resistors in parallel with each other, and the voltage sensor across it with the current sensor in series with the 33 ohm resistor. We will click to start recording data and then close the switch. And we're going to measure 1 joule of energy output through the resistor. Next, we will move our current and voltage sensors to measure the current and voltage for our 100 ohm resistor and repeat our experiment. We will click to record data, make sure the switch is closed, and stop when we've collected data for 1 joule of energy. When we look at our SPARKvue data, we see that our power is different for the 2 resistors in part 2, and it's also different from the power that was output by each of the resistors in part 1. In part 2, the 33 ohm resistor has the higher power output because while in a parallel circuit the resistors both have the same voltage drop, the current is greater across the one with less resistance. Power is a measure of how quickly energy is consumed in a resistor or other circuit element. How much power a resistor uses depends on both the resistance and how it is wired in the circuit. If you compare two resistors wired in series with the same two resistors in a parallel circuit, the resistors wired in parallel will consume energy faster, so the resulting power is greater.